You're wearing something older than the Earth. The gold in a ring, any ring, was forged before the sun existed, in a place so violent no ordinary star could survive it. Every fleck of gold ever mined is older than the ground it was dug out of, older than the oceans, older than the mountains. It was made out in space, long before there was a planet to bury it in. So where did it actually come from? Take that little glow and follow it backward, all the way to 2 dead stars. Start with how a star makes anything at all. It's a giant ball of gas, mostly hydrogen, crushing itself together under its own weight. In the core, that crush gets so fierce that atoms are forced to merge, fusion. Hydrogen fuses into helium, helium into carbon and oxygen, and in the biggest stars it keeps climbing, stacking heavier and heavier elements like bricks. Each time 2 light atoms merge, they let out a little burst of energy, and that energy is exactly what keeps the star lit and stops it collapsing. But the stacking only works up to one element, iron. When a star tries to fuse iron into anything heavier, the trick reverses. Instead of giving energy out, it starts swallowing energy up. Iron is the wall. For an ordinary star, it's the end of the line. So fusion, the thing that lights every star in the night sky, simply can't make gold. Gold sits far past iron, 79 protons crammed into every atom. That's too many bricks for a star's furnace to stack. If the normal life of a star can't build it, something rarer has to. So the very first clue is this: whatever made the gold in your ring, it wasn't one of the quiet, steady stars twinkling overhead. It was something that only happens when a star reaches the very end of its life, or past it. If you can't fuse your way to gold, how do you build it? You flood an atom with neutrons. Neutrons are one of the pieces inside every nucleus, and they have a handy quality: no electric charge, so they can slip straight into a nucleus without being shoved away. Cram enough of them in fast enough, and the atom grows heavy and unstable, then quietly rearranges itself into something new. Gold among the possibilities. Scientists call it the rapid neutron capture process, the R process, for short. That word rapid is doing real work. A free neutron drifting on its own falls apart in about 15 minutes. So to build gold this way, you need somewhere drowning in neutrons, and you need the whole thing over in seconds. Picture what that takes. A place with more neutrons crammed together than almost anywhere in the universe, hot and violent enough to slam them into atoms in an instant. That is not a calm, glowing star. That is a catastrophe. For decades, scientists knew the recipe by heart. They just couldn't say where in the universe the kitchen was. Then came the night we finally saw it happen. First, neutron stars. When a large star burns out and collapses, it can leave behind a tiny, absurdly dense core. A ball only about the size of a city, yet so heavy that a single spoonful of it would weigh about as much as a mountain. A whole star crushed almost entirely into neutrons. Now picture 2 of them, circling each other, drawing closer over millions of years until they finally crash together. On the 17th of August, 2017, we caught exactly that. Detectors on Earth felt a tremor in space itself. Faint ripples called gravitational waves, rolling out from 2 neutron stars spirally together in a galaxy about 130 million light-years away. And for the first time ever, telescopes swung around and saw the light from the same event. For all of history, we had studied the sky only by the light it sent us. This time, we felt the collision as a shudder in space, and then we watched it. 2 ways of witnessing one moment. What they saw was a glow, an afterburn astronomers call a kilonova, and buried in that glow was a fingerprint, the unmistakable signature of freshly made heavy elements, gold, platinum, silver, being forged right there in the wreckage of 2 dead stars. It was the first time we ever directly watched the universe make gold, and not a trace of it. The estimates vary widely, but that single collision seems to have made whole planets worth of gold and other heavy metals flung out into the dark. It would be tidy to stop there. Gold comes from colliding neutron stars, mystery solved. But the real science is better than tidy, because it isn't finished. The 2017 event proved that neutron star mergers do make gold. That part is rock solid. What's still genuinely open is whether they make most of it. Here's the puzzle. These collisions usually take a very long time, often 1 billion years or more for two neutron stars to finally spiral in. Yet when astronomers look at some of the oldest stars in the universe, the ones that formed very early, they already find heavy elements baked inside. There may not have been enough time for mergers alone to seed all of that. So the leading view today is that mergers are a major source of gold, but probably not the only one. There are other suspects. Rare, violent supernovae, the deaths of especially fast-spinning, strongly magnetized stars, might also cook up our process elements, and could have acted much earlier in cosmic history. We just haven't caught one in the act, the way we caught the merger. So it stays an open idea. And a newer clue. In 2025, researchers re-examined a giant flare from a magnetar, a neutron star with a ferociously strong magnetic field, that erupted back in 2004, and found a delayed signal that seems to match heavy elements being forged in the flare itself. A tempting hint that magnetars pitch in too, though it rests on a single event and the details aren't pinned down. So the honest picture is a collaboration. Colliding neutron stars, exploding stars, flaring magnetars, different cosmic kitchens, each may be adding its share. Gold is born in catastrophe. We're still working out which catastrophes and how much each one gives. Bring all of that back home, to the ring and the earth under your feet. Long before our solar system existed, generations of stars lived and died, collided, exploded, flared, and every one of those events seeded the darkness with heavy elements, gold among them, over enormous stretches of time that scattered debris drifted and mixed into a vast cloud of gas and dust. Then about 4.5 billion years ago, the cloud collapsed, and out of it came the sun, the planets, and the young molten earth, with that ancient gold already stirred inside. There's one last twist in how it reached your hand. When the early earth was still a ball of molten rock, gold did something inconvenient. It loves to bind with iron, and the iron was sinking. So most of Earth's original gold sank right down into the core, far out of reach. The gold we can actually dig up near the surface may have arrived a little later, delivered by a long rain of asteroids and meteorites that struck the young planet and dusted the crust with fresh metal. And scientists are still carefully working out exactly how that part unfolded. But the thread holds. The gold in a ring spent billions of years buried in rock, then got pulled up by human hands, melted, shaped, and slipped onto a finger. Every atom of it began its life somewhere out among the stars. So the next time you catch a glint of gold on your hand or on someone else's, you might see it a little differently. It isn't just metal. It's a survivor, forged in almost unimaginable violence, most likely two dead stars colliding, though the universe seems to have more than one way of making it. It drifted through space before there was a sun to shine on it, rode down through the birth of a whole planet, sank into the dark and rose again, and after all of that, it ended up here, resting quietly on a hand, catching the light on an ordinary afternoon. We spent a very long time not knowing where it came from. Then, one night in 2017, we finally watched the universe make a little more. The same atoms, the same quiet shine, carrying, if you listen closely, the memory of two stars that died so this could exist. Strange and lovely that something so old and so far away ended up so close to home. Oh, one more thing. If the world feels a little more amazing than it did 10 minutes ago, there's a subscribe button somewhere near this little glow. Go on, give it a gentle press. There's a new calm little mystery freshly forged, waiting for you every week.